Welcome back everyone to Digital series on FluidSIM. In this video, I'm going to show you how we can basically design a pneumatic circuit for a specific industrial application. Without further ado, let's start looking at the example and then working on the FluidSIM circuit. So for this example, basically we have a double acting cylinder which is used to move glued components. Upon operation of a push button or foot pedal, the clamping cylinder extends. Once the fully advanced position is reached, the cylinder is to remain for a few seconds and then slowly retracts to the initial position. The speed of advancing and retraction should be adjustable. A new start is only possible after the cylinder has fully retracted. So if you look in here, we have a few important information given. So if you are dealing with a system in which we are asked for designing of a basically pneumatic circuit in which we have to use a double acting cylinder, definitely we have to purchase a double acting cylinder for that system. So that is clear. And then we have a push button or foot pedal, which means we would have a directional control valve as a signaling elements, and those directional basically control valves are actuated with a foot pedal or a push button, right? So that is another important information that we have in here. And as you can see, we have one OR in here, which means we have to use OR logic valves, which is basically shuttle valve, right? So the other thing that we need for this specific cylinder is a shuttle valve. The clamping cylinder extends. So the actuation is started with the push button or foot pedal. Once the fully advanced position is reached, the cylinder is to remain for a few seconds and then slowly retracts to the initial position. Here for this sentence we have two important information. The first one is basically the time delay valve that we are using in here, because it says it remained for a few seconds, which means we should use a combinational valve, which is in here a time delay valve, and then it says it slowly retracts to the initial position, which means we have to use throttle check valve. As you might remember, we had a video on time delay valve and also a video on throttle check valves, how they basically work. And in order to have a speed control over the actuators, we need to use basically throttle check valve. And the speed of advancing and retraction should be adjustable. So again, it is talking about a speed of the actuation, which means we need to use throttle check valves on both basically advancing side and retraction side of the double acting cylinder. And the very last point is looking at the starting position of the cycle, right? And it says a new start is only possible after the cylinder has fully retracted, which means we should have basically a valve which can check for us we are in the condition of fully retracted position. So it can be a directional control valve, right, with a mechanical actuation, and that mechanical actuation is linked to the position of basically piston inside the double acting cylinder. Whenever it reaches to the fully retracted position, that basically directional control valve is shifted to the second position, assuming the first position is the closed one, therefore the air can pass, right? And from there, after that directional control valve, we should have a twin pressure valve, right? And as you know, twin pressure valve has two inlets. One of them is going to be in the actuation mode, because we're assuming, okay, the system is fully retracted. The directional control valve, which is linked to that position, is actuated and shifted, right? One condition is true, therefore the system is ready for the new cycle. And the other side of basically twin pressure valve is connected to the signal coming from the push button or the foot pedal, right? And once we push the button or the foot pedal, we can have both conditions met for the twin pressure valve, and from there we would have basically the start of the cycle. So that is how basically in general we look at the problem statement in pneumatic circuit. I brought this example from Festo, the textbook, pneumatic basic level. So now we have a good understanding of what's going on for this specific circuit and what's going on in this problem statement, and how we can basically look at the information given in the specific problem, right, related to the pneumatic system. It's time to start designing the specific circuit needed for this problem with FluidSIM. Okay, we saw the example, right, and the problem statement, and now let's look at the FluidSIM, see how we can design the circuit inside FluidSIM. So what we have initially is basically the actuator, right, and the problem says we have to use a double acting cylinder. So the first thing is going to be the double acting cylinder added to the circuit, and then we need to bring different components for the certain functionality needed for that specific example. So the first thing for any pneumatic circuit that we design is basically the air supply. So we have to go to the supply elements, compressed air supply, right, and we need to have air service unit, right. So I'm bringing the air service unit here, and we also need to have manifold, right, manifold air service unit. And once we have all of them, we can basically connect them. So I'm going to connect this one and then this one, right. And once we have this, the problem was basically looking at basically two forms of actuation for a starting of the cycle, right. One of them was foot pedal, the other one was push button. So we can bring two directional control valve with 3 ports, 2 position, and then we can configure them based on what the problem is saying there, right. So we need to bring the directional control valve, which is configurable. So that is going to be the first one, and we need the same thing basically, and we have to configure both of them. So for the first one, we go to configure valve, and because it's going to be a manual actuation, right, spring return, that is set. Now the second one, it is going to be a foot pedal, right, again a form of manual actuation. So I'm going to select foot pedal, spring return, hit OK, right. Now we have everything set in terms of configuring these two directional control valves. We have to basically connect them, right. That is connected. The second one is connected too, right. So we have both of them connected, and we need to have the exhaust, okay. So this is the exhaust needed. And then it is saying, or basically we can use push button or foot pedal, right, to start the cycle. So we need to have a shuttle valve. So the shuttle valve is located inside the flow control valves, right, and that is basically the shuttle valve. So we connect this here, this one, right. So that is the valve needed for that specific word of or inside the problem statement. After that, we need to use a twin pressure valve, and that twin pressure valve is used to check basically the condition needed for the start of the cycle. So we would have a twin pressure valve. Again, it is located inside flow control valves. One side of that is going to be connected to this twin shuttle valve, and the other side is going to be connected to a directional control valve with a mechanical actuation. So for doing that, I'm going to bring a directional control valve, which is configurable, right? So I'll bring this one here, and going to put a mechanical actuation with roller, valve, spring return, and hit OK. And I'm going to connect this here. Right now we have everything set in terms of basically air supply for this part and connection to the twin pressure valve. This is the exhaust, and the next component that we have to add here is basically a directional control valve, right? So we need to bring a directional control valve there with 5 ports and 2 positions. So we have to go to the directional control valve configurable one and choosing this one, right? And this is going to be pneumatically actuated from both sides. So I'm going to choose this for the left actuation and the same thing for the right actuation, and then connect this to this to the twin pressure valve that we have in here, right? And this is going to be connected to the air supply. Now air supply needed for this directional control valve is there. The exhaust should be connected, right? So we have to provide a terminator here, and the same thing for the other side, the terminator there, and hit OK. So we have the terminators set, we have the air supply set. The problem was saying about the adjustability of the speed, right? And for both retraction and advancing, therefore we need to have throttle check valves, and we would have the capability of changing the opening level of throttle check valves. And once we have this capability, basically we can adjust the speed of the actuation here, right? So what I'm going to do is basically bringing 2 throttle check valves, right? Throttle check valves are located here. So what we have to do is I'm just going to rotate it 180 degrees and then mirror it horizontally, so that will allow the system to have basically the free pass in this side, right? And once we would have the retraction, right, we can control the speed of the retraction based on this. So connecting this here, so this is the first one that we need, right? And I'm going to use the same configuration, putting it this side and connecting here, connecting this one here, right? So we have basically two throttle check valves here, right? And the next step after this is looking at the time delay valve, because the problem is saying when the system reaches to the fully advanced position, it will stay there for a few seconds, which means we have a time delay valve. So for time delay valve, based on what the problem is saying, we should have a normally closed time delay valve. We should go to valve groups, and then inside valve groups we have to select time delay valve, as you can see here. And now in order to configure this time delay valves, this side basically should be connected to the air supply, and then here we should have a connection to a directional control valve, and that directional control valve is basically connected to the position of piston within this double acting cylinder. So I'm going to bring a directional control valve with 3 ports and 2 positions. So that is going to be the directional control valve needed. I'm going to connect this here, right? And this one is going to be connected to the air supply, the manifold basically, and therefore to the air supply. And here we would have the terminator connected. Hit OK, and then here we would have connection between the pneumatic actuation and this time delay valve. as the problem is saying for a few seconds, we have two options. As we already discussed, the time delay valve, we can change the basically the volume of the reservoir, right? And from there we can increase the level of the amount of time delay, right? So I'm going to change this to 0.3, right? Then hit OK, and that is basically set for the amount of time delay for a few seconds, but we can be a bit more specified. If the problem is saying, okay, let's say 6 seconds, we have to basically adjust the reservoir and the opening level accordingly. Then here I'm going to basically use the mechanical actuation. This side is going to be spring return. Now everything is set in terms of the components and different basically linking and connection that we need. The next step is basically labeling each of these components. So I'm going to call this one 0Z, calling this one 1Z. This is going to be called 1S1. I'm going to call this one 1S2. This one I'm going to call it 1S3. Here you would have the valve 1V1. This is going to be 1V3. This is 1V4. One V5, 1V6, and that is going to be called 1V7, right? So that is 1V7. Hit OK. And I'm going to call this one 1A. Hit OK, and here we are going to have 1S4. Then hit OK. So we have all components labeled. The next step is basically, if you remember, the problem was saying, okay, when it is in the fully advanced position, it remains there for a few seconds, but we have to connect that position to a directional control valve, and when it reaches back to retraction position, we should basically inform one directional control valve from that position. Therefore, there should be labeling and linking between that position and a directional control valve. So based on that, I'm going to put the actuating labels. For the retraction side, when it is basically fully retracted position, it is going to be linked to 1S3, right? And hit considering 0 because that is going to be the initial position. And as the maximum stroke is 100 millimeters, so 1S4 is going to be 100 millimeters, right? And then hit OK. So from here we can see now the system is ready, right? We connected everything and we configured it based on every sentence given in the problem, right? So if we start the simulation, we see like the system is ready for the actuation, right? And we have this stream pressure valve, right? And basically here we are checking that position basically, right? If I push this button, the system will start. Otherwise, if let's say if it is in the middle of the operation, we cannot start the cycle again because we cannot check the position here, right? This stream pressure valve is not going to meet those conditions, right? So if I push this button, the system is going to start the cycle, right? And here, because we already set the time delay, we'll stay there for a few seconds and then will send the signal to this pneumatic side and pneumatic actuation, and from there we'll get the actuation for this circuit. So let's see again. If I actuate either 1s1 or 1s2, we would have the actuation. So if I push this one, right, because we have a shuttle valve here, the air will pass to this stream pressure valve. One inlet already in basically in the through condition, and the other side will be through. Then air will pass, and from there you would have actuation shifting to the second position. Air will pass through this throttle check valve, getting to this double acting cylinder. And with these two throttle check valves in here, we basically have the capability of adjusting the speed of the piston in there. So let's start again. You see we have a time delay, and then once the time delay is passed, it sends a signal here because this is going to shift to the second position, right? If you remember, the time delay valve will shift to the second position, the normally closed one, and it is going to be open. Air will pass from this side and it gets here, and this is going to be pneumatically actuated. So that is how we basically look at a problem given in industrial application, and we look to different components, right? And we use those components that we already discussed for a certain functionality within a pneumatic circuit. Thank you for watching this video. Hope you enjoyed. If you enjoyed, please subscribe our channel.